In order to reduce sound transmission, which is from one space to another, you generally need density, you need mass, you need something big and heavy. Drywall manufacturers have come up with a very clever system that effectively utilizes a cavity construction that uses some mass. It uses that cavity with an air gap in between, but it then has another layer of density or mass on the other side. And the sound is effectively either absorbed by the mass or it's trapped within the cavity. The soft finishes you were talking about, that is simply to reduce the excessive echo or reverberation within the room. So a good acoustic solution will have an element of both of those. That combination and the amount that is contributing to each of those is exactly what somebody like myself looks for in the design and advises the architect of exactly how to achieve that.
In a world increasingly facing the challenges of climate change, with the Building Green podcast, we will dive deep into the intersection of architecture, design, urbanism, and environmental responsibility. I'm Ladina Schipf, your host. I've been an architect and building site manager for the past 10 years. During my studies at ETH in Switzerland, as well as in my working environment, I've had many touchpoints with sustainability, like many of you, I guess. I've also learned to question what I've been told, which is why I decided to go deeper into the topic and uncover what sustainability actually means. My mission is to highlight the transformative power of sustainable architecture, not just as a practice, but as a catalyst for broader societal change. Subscribe for more of our content and enjoy the show. So, Paul, you've dedicated your career to the field of acoustics within the architecture and planning industry. Can you explain to our listeners why acoustic design is not just a luxury, but a necessity for the sustainability in our built environment?
The requirement for acoustics, noise and vibration within certainly residential spaces, but the fact that it touches on every building that we live, work, play, and gets interacting on a daily basis. It's the aspect of sustainability is the multiplication or the lengthening of the use of that building for the purpose that it was designed for. Acoustics, noise, and vibration starts to become much more important the closer that people are interacting, either living, working, or playing in proximity to each other. If we all had an unlimited amount of space, then really it wouldn't matter that much about how much noise was being made, or if we had equipment that was making excessive amounts of vibration, because the only people that would be disrupted by that would be ourselves. And I think it's pretty widely understood that we generally tend to not be that disturbed by noise that we create ourselves and within our own environments. It's only when a noise or vibration is created by somebody else, and it's maybe something that we are not expecting within our environments, that it might become a problem. And I think everybody is well aware of the adage, or I guess the description of when you can say, for example, music. It might be that AC/DC, one of my favorite bands, that to me and other people that like that kind of music, that's sound. But to other people that might not be so attractive to, then it becomes a noise, because it's a sound that is effectively unwanted. And if it's a sound that is unwanted and unexpected, then it tends to become a problem. So that is why we have regulations that exist in various guises all around the world that protect people from unnecessary and unwanted sound or noise to a certain extent. I don't think anybody is ever expecting complete haven and peace and tranquility in every part of their lives. I mean, at the end of the day, noise and sound to a certain extent play a very important role in everybody's life if it comes down to simply communication. Sometimes loud and unwanted noise actually gives us good amount of information. It could be that it's an emergency or warning klaxon telling us that something is about to happen, or we're in an area where we need to take special care and attention. So eliminating sound and noise isn't always the target, isn't always the objective. It's to really control the sound and the noise and keep it within acceptable and expected levels where it does not necessarily need to create a problem, but also the fact that we might go into a theatre or a concert hall or a public performance venue. So it's not about reducing the sound in those environments, it's about enhancing it. So as long as there is a decent balance that is struck between the kind of sounds that we need and we want in our everyday lives and trying to minimize those that create a problem or create an issue with regards to restricting people's enjoyment of their personal spaces, whether it be where they live or they work. But also the sustainability codes. Those exist to enhance those local authority, those rules and those regulations to give additional incentives to contractors and developers to ensure that they really are achieving levels that are a little bit more appropriate given the various range of developments and buildings that we live and work in every day.
As I said before, to me, even though I'm an architect, it's actually mind-blowing. I've never thought about noise or acoustic insulation as a measure of making a building more sustainable.
Well, and you're not alone in that because, I mean, there are a lot of specialists within the construction industry that will say that it's rare that anybody notices the job that they do until they do something wrong. And to a certain extent, I think most architectural acoustic engineers would probably agree with me that all the while that we do our jobs correctly, i.e. we're helping to design a building that is quiet, usable, one where you can have a decent conversation, where you can hear the majority of the content of the conversation perfectly well. You might be in a cinema and you can't hear the noise from the cinema next door. Well, all of those things are just kind of expected. And all the while that you're in a building where you can talk, you can communicate, you're not getting distracted every few seconds by strange and unwanted sounds. Well, quite frankly, people don't notice because they're simply in the building and the building is doing what it's supposed to do. You will notice, however, if you're in a cinema and there is a noise coming from next door, it's one of the first things that you notice and you think, well, that's odd, that shouldn't be happening. Or if you're in a meeting room and you can only hear half of the words that are being said because the room is so reverberant, there's a lot of glass, there's a lot of concrete, or there's a lot of marble, and so it interferes with the speech intelligibility of the room. Well, again, it's one of the first things that you're going to notice when you're sitting in that room. But if you can hear every word that somebody's saying, you don't notice. You think, okay, well, the room's fit for purpose. The room is doing what it's supposed to do. So we get that a lot in acoustics. You'll find a lot of people feel like people only notice things when it's done wrong rather than when it's done right, because people don't hear. They don't notice.
So your goal is to not being noticed.
Exactly right. We try and keep quiet and keep in the background. And if we do our jobs well, nobody notices that we're there. Exactly.
How do you see sound influencing our standard of living and overall health? Can you share some of the research or experiences that highlight this impact?
Yeah. So the World Health Organization and the various European health associations, there's been quite a significant amount of research done into the effects of excessive noise and how that might, for example, affect people's quality of sleep at night, their ability to concentrate during the day. The brain, as remarkable and amazing as it is really only capable of producing or processing a certain amount of information that we are conscious of. If a lot of that processing power, processing availability is taken up by having to filter out unwanted noise, it's being distracted consistently, our focus is being broken, and we're having to constantly refocus ourselves or get ourselves back on the target of the conversation that we're having. It's incredibly tiring and it's very stressful on the body. And especially when it comes to our time at the end of the working day when we go home and we need time to decompress and relax and be in a relatively quiet environment compared to the rest of the day, particularly at night when we're trying to sleep. So a lot of those studies have shown that when the body is exposed to excessive amounts of stress because of excessive amounts of noise that is taking away our ability to sleep and decompress in the evening, that directly affects the body's ability to deal with that stress. And over a long period of time, that results typically in a greater prevalence of things like heart disease, excessive stresses in life. Yeah, very much, I guess, a biomedical response to that. So at the end of the day, it's not only good for your concentration and your immediate well-being, but there are serious long-term implications of exposure to excessive amounts of noise. Not least of which, I mean, everybody has heard the more obvious ones. For example, exposure to loud noise will reduce your ability to hear. I've been reading more recently, and I don't know if it's been followed up with peer-reviewed research, but there is now more recently a significant number of studies which are linking things like dementia. They have found a direct link between people who are hard of hearing and a direct or so much an indirect link to dementia, whereby they feel like people who have got reduced sensitivity to hearing tend to be a little bit more removed from society. People feel a little bit more self-conscious about the fact that they cannot communicate as well with other people, they have hard of hearing. And so what tends to happen is subconsciously they start to withdraw themselves a little bit more from society, from those conversations, from those personal interactions that they have, especially when their hearing was a lot better at a younger age. And then when they find themselves more removed socially, that's when they start to see a more pronounced decline in, I guess, cognitive processing skills. And then effectively that would just accelerate the onset of things like dementia and related medical, psychomedical effects like that. So there's an interesting indirect link. And I've got to do a little bit more reading on that, but there is a long-term and a short-term implication, very well researched.
It's amazing. Now, actually, now that you mention it, I think I've heard about it also, that it kind of speeds up the aging process as well, or the dementia process. Yeah, it's amazing. So I often work with my AirPods in my ears or listen to music while I work out, and there is like a noise limit on the AirPods where there is like an alarm. Be careful, it's dangerous. What is like the range of decibels that you recommend in a daily environment?
Well, typically most health and safety executive branches, and I will really just cite the UK one here, recommend that your daily limit for noise, you need to start thinking about the amount of noise that you're exposed to when you get above 75 dB. And that's kind of like an average over a certain time period. And it recommends that you need to start taking action on that at around about 85 decibels. So that is based over a typical working day, whatever that is these days, because obviously, since COVID, people are in very much different working environments and I guess are exposed to very different noise levels over their working day, depending on what their job is. But typically the understanding is that 85 decibels averaged over a typical working day, but that limit reduces very quickly, or rather the time that you're recommended to be exposed to that limit reduces very quickly as that level increases. So, for example, just 3 dB higher than that, which is effectively a doubling of the amount of sound that you're exposed to, 88 being double that of 85, because it's a logarithmic scale. It's not a linear scale. So if you double the amount of noise that you're exposed to, in order to ensure that you're not exceeding the kind of the daily allowance that is typically recommended. If you double that noise level from 85 to 88, what that is effectively saying is in order for you to be exposed to the same amount of noise over the day, you need to halve the amount of time that you're exposed to that to. So just by increasing the noise level from 85 to 88, that limit of exposure goes from 8 hours down to 4 hours. So if we then increase that noise level by another 3 dB, let's say, for example, so therefore it's up to 91, that is then reduced to 2 hours. Another 3 dB reduces it to 1. Another 3 dB reduces it to half an hour. So you see here very quickly, you can easily be exposed to noise levels where you really need to think about your daily exposure level. Just standing on the side of a fairly busy road, I mean, that's 85, 90 dB right there. So if you're in a fairly crowded bar, or you're somebody that likes to go to music concerts, or you go to a nightclub, those noise levels can get up to 100, 105 very easily. And if you think about that scale that I've just mentioned, what the daily typical exposure level is going to be, you can really only be in that environment for about 10 or 15 minutes before you used up your full daily allowance of noise.
Wow.
And I don't know anyone that's ever gone to a concert or a nightclub really only for 15 minutes and then looking at their watch going, oh, no, that's my exposure limit gone. I've got to go home now. No, we go through, which is why generally into early middle age and then certainly into more advanced past middle age, you see a very quick decline in sensitivity to hearing that a lot of people face in their life.
Is it true that at some point if you're exposed to super high level, that your eardrum can explode, or does it just mean that your ability to hear will decrease much faster?
Well, I mean, the explosion of the eardrum, I mean, I'm not a medical practitioner. I can't really talk to the physiology of the ear so much, but I am certainly aware of the damage to hearing. The cells that are in your inner ear, and this is a fairly little known fact, but those are one of the few cells in your body which do not have the ability to recover and regenerate. A lot of the cells in your body do. The hearing cells within the inner ear are one of the few that cannot regenerate. So once you've damaged them, they're damaged for life. This is why it's very difficult for those who are hard of hearing, especially in advanced ages, where one of the only solutions available is electronic hearing aids. It's not as if anyone can undergo any kind of surgery or take a bottle of pills for 6 months and all of a sudden their hearing gets better. It's a situation that people really do have to look after their hearing, because once it's gone, it's gone.
So now that we covered the biological aspect, let's get back to architecture.
Yes, please. That's something I'm a little bit more familiar with. I'm not, as I say, I'm not a medical expert. I'm only familiar with these concepts because obviously it's related to my industry and I tend to read around it. But yeah, nobody should be coming to me for medical advice.
You mentioned that our working environment since COVID has changed. So for our homeowners listening, what are some immediate steps they can take to improve the acoustics of a specific room, like a home office? Could you also discuss the tangible benefits of such improvements in their daily lives?
Yeah, okay. Well, the good thing is that generally home environments, when they don't have other people around, people being one of the main sources of noise that we have to factor in and take into account what we do. But if somebody's working from on their own at home environments tend to be very well suited for those kind of environments. Essentially, you want a low noise background level, so one where the ventilation systems or the air conditioning is not exceptionally noisy. Or if you don't have air conditioning where you need to open up the window to get ventilation, as long as it's not an excessively noisy area, that's fine. And generally within habitable spaces within home environments, there are enough soft furnishings in order to absorb enough of the reverberation within the room to make it a reasonably pleasant environment, and to make sure, for example, I can hear every single word that you're saying, and I can't hear exactly what my sound sounds like on your side, but there's a reasonable amount of furnishing within the room that I'm in now, albeit there are marble floors and there are tiles on the wall, but there's not excessive amount of echo or reverberation. I suspect you're probably able to hear a lot of what I'm saying perfectly well. So I would say home environment is actually pretty well engineered already to be very good for conference calls. I've not really experienced any recently where I haven't been able to hear the person on the other end of the line. Only, and I've got two of them myself, where you have children running around and treating the living room like a playground whilst you're trying to make a conference call. Then it tends to be a little bit of a problem. But honestly, there's not much an acoustic engineer can do to help keep a child quiet, except maybe suggest a quiet DVD or a packet of sweets.
So that's a great tip, I guess. And in an office environment, if you have several people talking, you mentioned soft furnishings. I guess that's maybe some pillows on the couch, carpet, something on the walls, maybe something on the ceiling. What do you recommend there?
Yeah, exactly. Okay, so one of the things that needs to be somebody who's designing a commercial space needs to be cognizant of is that there is a difference between the stopping of sound transferring from one part of a space to another space, sound transmission as we refer to it, and the absorption of excessive amounts of sound that are bouncing around the room, which we generally call reverberation. The reverberation aspect, it really speaks to the ability of someone to understand what you're saying without those excessive reflections coming in and disrupting what I am saying, as in the echoes or the reflections interfering with what I'm saying. If the privacy or the reduction of sound transferring from one space to another space, really the best way to deal with that is with a solid partition, and it's with a partition that doesn't have any gaps in it. However, there are situations like a call center or a situation where you've got a lot of people hot desking in an open plan space. And we fully understand that open plan space is a very efficient, very effective way to get a lot of people into a relatively small area. Not everybody can have their own private office. We completely understand that. However, there are certain things that you can do. You can use screens or panels between adjacent seating areas that can be also have an acoustic or absorptive lining. So as long as there isn't the expectation that you're going to have complete privacy, but it can be minimized to a certain extent. But at the end of the day, nothing is going to stop someone who's got a very, very loud voice and that voice transferring from one side of an open plan office completely to the other. Then there's only two ways of dealing with that person. Either you give them their own space or you put something over their mouth to stop them talking generally. But the majority of people understand that you don't raise your voice in an open plan space. But if complete privacy is required, then maybe what a lot of commercial spaces are doing now, they're providing either phone booths or specific rooms that people can go to if they think or suspect that they're going to have an animated conversation, so that they don't disturb everybody else in the open plan space. But generally, you're correct. It's about soft finishing. It's about carpeting floors. It's about providing the appropriate finishes on the ceiling and the walls to just make sure that the communication is as understandable as possible.
But so are these acoustic panels on the walls and on the ceilings, a lot of, for example, podcast studios also have them, are they more to prevent echo rather than to like take out the voice of your neighbor talking?
Well, in an ideal world, you'd have a construction and a design that does both. In order to reduce sound transmission, which is from one space to another, you generally need density, you need mass, you need something big and heavy. The gypsum drywall manufacturers have come up with a very clever system that effectively utilizes a cavity construction that uses some mass. It uses that cavity with an air gap in between, but it then has another layer of density or mass on the other side. And the sound is effectively either absorbed by the mass or it's trapped within the cavity, which is why you sometimes have insulation within the cavity that then absorbs the sound that gets trapped in the middle. The soft finishes you were talking about, that is simply to reduce the excessive echo or reverberation within the room. So a good acoustic solution will have an element of both of those. One part of it will be to stop with the mass in the wall, to stop, or the ceiling, to stop the sound going from one room to another. And the other aspect will be by the finish on the surface area that is exposed to the room, that will absorb that sound and stop it from bouncing around within the room, which will then interfere with the speech. So it's an element of both. And that combination and the amount of that is contributing to each of those is exactly what somebody like myself looks for in the design and advises the architect of exactly how to achieve that.
So we are currently planning a building project, a new build. And of course, there are like the concrete walls that bring in the mass. But for example, the staircases are an element that our engineer wants either like well connected to prevent them from vibrating towards each other, or separate so they vibrate differently, like they don't touch each other. How do you decide one?
Vibration within a structure, it's not something that you'll ever get if we're like you and I talking right now. No, neither of us is going to really excite any vibration within the floor or any of the walls with what we're doing. That generally tends to come through large building mechanical services, or it might be if there was a metro or a train line or a highway nearby that sets up those vibrations within the structure and within the building. So in an ideal world, building services, fan units in the ceiling or generators in the basement, those would be on anti-vibration springs to stop those vibrations getting into the structure. But as I say, the kind of sound energy levels that you and I are generating by having a conversation, that's really not going to be affected. It's not going to get into a concrete structure and be able to travel through the building. So that kind of separation is not really required. But if you think about it in a way, concrete is obviously a very dense, a very massive material. It's very effective at reducing sound to going from one part of the building to another. But the thing is, if you think about a concrete corridor, it's also very effective at transmitting sound all the way down that corridor, because the sound will simply keep reflecting off of the sides of it. So what we tend to find with stair cores and lift cores and other massive structures at the center of a building, we find they're actually very useful in one aspect to protect one side of the building from the other, because of the amount of mass that's involved. But if you're not careful, you could have like a basement mounted generator that might be getting vibration into the structure. And then you've got a perfect conduit to transmit that vibration up the full height of the building, potentially. So our best recourse, and what a lot of acoustic consultants will look at, is to try and look at where the source of the noise is coming from, and we deal with it at the source. So if it's a generator that's creating vibration or noise, we would deal with it within the generator room, or actually with how we look at the connection of that piece of equipment to the structure there and then. Or if it's another piece of equipment, we try and deal with it as close to the source as possible. Because once that noise or that vibration has gotten out of that area, it's very, very difficult to then control. It really could go anywhere. And it just means that the cost financially and in terms of resources of dealing with that noise source just gets multiplied the further away from it that you get. So always best to deal with it at the source. But where one person or one item that you might think could potentially be a problem in another situation could also be a solution. As I mentioned, the stair core or the lift core is a potential conduit for vibration, but what a lot of acoustic consultants will uses those massive structures to also isolate against airborne noise. So another good reason for having an acoustic consultant involved in a project, because we're able to put a little bit more detail on what really constitutes a critical issue or a problem, but what actually could be used to help solve that issue as well.
A few of you might know that I recently opened my own architecture studio and I just started with the podcast. I'm very excited to build a platform where I connect with inspiring people to learn along the way and share these learnings with you. So if any little thing has inspired you or if you learned anything new, I'd appreciate if you could rate the show or share my content on social media, Spotify or YouTube or wherever you listen to it. And if you think there are any touch points between you and me, I'd be super happy to connect with you. Feel free to reach out on any platform. And so what has gone wrong in the planning or the construction of the building I currently live in? It's a new build apartment, more or less new build. And every evening I hear that woman walk home through the corridor with her high heels.
Yes. So most building regulations in the world will have not only a component that deals with noise. So obviously, if you were to play music in your apartment on a sound system, but they also generally tend to have a requirement for impact sound transmission as well. Now, normally, if a structure, and let's just say typically you might have concrete floors that separate one floor of an apartment from another floor. Normally, if they're in the region of 250 or 300 millimeter thick concrete, there's normally enough mass within that to deal with most of that. It's not a complete catch-all because there will be some times if even with the 300 millimeter thick concrete slab, if we were to start picking up chairs or banging the living room table, that's going to be heard in the floor below for sure. One very effective way of dealing with that is what's called a resilient layer. And you get some impact isolation suppliers and manufacturers that manufacture a rubber or a neoprene core that's around about 5 to 7 millimeters thick. That would normally sit between the structural slab and whatever it is that the floor is finished with. It might be tile, it might be a sand cement screed, but that is supposed to do the job of absorbing those impacts, those vibration, and stopping those sounds getting through the floor into the apartment below. So either somebody forgot to put that in your apartment or somebody upstairs is wearing very, very large high heels. That's the only two things that I can think of.
Sustainability in building materials is a key concern for our listeners. When it comes to acoustic panels and other soundproofing materials like the one you just mentioned for the floor, what are the most eco-friendly options available on the market today?
Unfortunately, and with a lot of aspects to do with acoustics, noise and vibration, we are very rarely responsible for reducing materials that go into a project. And unfortunately, the most effective, efficient, and the most effective, efficient, and high-performing materials, unfortunately, tend to be those that are not exactly renewable. I'm sure there's research going into various products all the time. For example, let's just take cork. Traditionally used a decent amount of time ago as a reasonably good vibration isolation material. It has some semi-decent sound absorption properties also. However, it also tends to not last, unfortunately, over significant periods of time. And it does tend to be a little bit susceptible to, when exposed to chemicals, various chemicals, it tends to kind of break down the bond that you get within the material, within the material itself. Now, I'm sure there are one or two manufacturers out there that may have some kind of chemical additive that will protect against the chemical deconstruction because of exposure to oils and various other materials, or they may have found a way to enhance the sound insulation properties. However, the vast majority of experience of acoustic consultants in the industry is that kind of renewable material, unfortunately, doesn't work as well as the materials that are, as I say, unfortunately, not quite as renewable. So we don't have a huge reputation for it, but certainly within the acoustic consulting industry, we are very well aware that in order to achieve what we need to achieve within a building. We generally ask for more materials to be used because we need more mass, we need more density, although that can be cleverly used with a combination of air cavities, as I mentioned before. But generally, in order to achieve the kind of timescales and within budgets that most buildings are restricted to, generally systems that have a little bit more mass, a little bit more material in, unfortunately tend to be the more effective at providing better sound insulation and acoustic absorption. However, me and my team, we as part of the Dubai Acoustic Research Laboratory, because we have that ability to do research and development into products, we get a lot of companies and products that are given to us all the time, and we're asked if we can make them more efficient, if we can improve the acoustic performance of those materials without using any more actual physical resources. And so in that respect, we like to think that we're at the forefront of helping to make these products and these systems a little bit more efficient if we can increase the performance without using more material. However, unfortunately, the tried and tested method, and the method that a lot of developers and contractors keep coming back to time and time again, are the tried and tested ones, where unfortunately you use a little bit more material in order to get the job done.
I like the honest answer. I like that you're not trying to tell me that it's not as bad as it seems. So your focus is not on using sustainable materials. Your focus is on using the best, most efficient materials that help the longevity of a project.
Yes. No, I mean, not only the longevity of the product, but the project rather, but also that if we do our job correctly, and although in the immediate term it might look like, and it is actually, the use of more materials, but if, for example, we can provide a structure or a building that allowing more people to live within a closer proximity to each other, that is a kind of a secondary victory in terms of sustainability, because we're able to reduce the footprint of the building itself by having a larger number of people live happily more closely together.
That's wonderful. Moving outside the home office and our buildings, let's talk about outdoor noise pollution. How does it affect our ecosystem, and what measures can be taken in urban planning to mitigate these effects?
So, yeah, I think a lot of people get caught up in how noise affects humans, how noise affects us in our daily lives. But we obviously are not the only creatures on this planet, and we need to be very much aware. Well, I think we could be a lot better aware of how the noise and the vibration that we take for granted and that we create in our everyday noise is actually affecting the other creatures that we share this planet with. And there is a significant amount of research that shows that especially aquatic life is seriously impacted by humans and the human activity in terms of shipping, and the noise and the vibration is created by the very large cities that are on the coastal areas, especially the industrial infrastructure that we've put in place, water desalination plants or any kind of industrial facility that needs to be closer to the water. I'm sure nobody would be surprised to hear me mention about the low frequency noise that is created by the wind turbines, for example, which are in rural communities. Germany has certainly done a lot of research and development into attempting to reduce the impact of these, because they were one of the first adopters of that renewable energy source. It does seem, though, that whenever we try to do the right thing and take a nice big step forward in terms of protecting the planet in one area, we do seem to be taking half a step backwards and negatively affecting it in another area. So at the end of the day, I think it's just being aware. It's being cognizant of what we're doing and be aware that for every advancement in technology, there is a potential downside to it. And any technology or solution that creates noise and vibration, that humans aren't the only one being affected by that, it can be minimized and should be minimized just simply with planning foresight, with predicting what those issues are going to be. But not only that, but when the technology is up and running and it's been handed over, just to keep monitoring it and look out for the effects on the wildlife and look out for the effects on the wider community that technology is imparting, because I don't think anyone is going to put their hand up and say they're able to think about and predict every possible outcome of every advancement in technology. But it certainly, if we just had our eyes open after the handover and the operation, we can see what effect that is having. And if it's having a negative effect, let's recognize that and actually try to do something about mitigating it.
I'm really testing your limits here as a researcher, but do you know the effects it has on the animals' lives?
Well, okay, so it's not dissimilar to the effect on humans, really, but the thing is, when sound, for example, gets into water, because water is so much a more dense medium than the air, it is so much more effective and efficient at traveling much greater distances. And you will get a much wider range of frequencies that also can be transmitted over longer distances. So one of the effects that the research has seen is on aquatic life is the ability for animals to communicate. And when we are effectively disrupting the channels through which the aquatic animals communicate, that will inevitably have an effect on their stress levels, their ability to reproduce, their ability to hunt food. It affects every aspect of their life. And you can translate those similar effects to airborne noise for land-based and air-based creatures that obviously away from aquatic life. Again, if the noise and the vibration we are creating is disrupting their ability to communicate, reproduce, and hunt for food, we're effectively we are changing their ecosystem, and we're really forcing them into a Darwinian situation where it's really only the more flexible or adaptable creatures that find a way to get around that problem that they have not created. Those are the ones that survive and go on to obviously reproduce and develop. But I don't have any hard evidence to back this up, but if I were to hazard a guess as to one of the major reasons as to why we've had so many animals' numbers decline over the last few decades and hundreds of years, I would not be surprised to see if that coincided with the development of technology and mechanical instruments and technology that humans have introduced into the world.
Technology is continuously evolving. In your expert opinion, how has technological advancement shaped acoustic design, and what exciting innovations can we expect in the future? To not just talk about the bad effects.
Yeah, absolutely right. So, I mean, I think one of the most obvious things in terms of acoustics is twofold. One is that just like many other industries, we use computing power to do an incredibly large number of calculations in a short period of time. So whereas in the past we would have very limited ability with a piece of paper and a pencil, or indeed a calculator, to predict the kind of acoustic environment that we would get either outdoors or in an indoor environment because of the number of calculations required to be done. Now, with computing power and the ability to do millions, tens of millions, hundreds of millions, thousands of millions of calculations every second, we're able to build incredibly complex models and predictive models within software now, much easier than we could do before. So therefore, the accuracy of our predictions of how sound travels through the external and internal environment is that much more accurate now. But that technology is also fed into our ability to measure and analyze those noise levels. So whereas before we were beholden to analog technology that would essentially be a dial moving on an analog piece of equipment, now we have digital sound level meters and digital analysis software that, again, is able to capture and assess a huge amount of data in a very small amount of time. So as long as that data, and like any industry, as long as that data is used in the right way, it has increased the acoustic engineer's ability to assess and predict what is likely to be the future environment if the right advice was to be taken into account. So I would say it hasn't really fundamentally, well, it hasn't changed the laws of physics. It hasn't changed the way that sound propagates and behaves in certain environments, but it certainly has remarkably improved and increased our ability to assess that and predict it accurately. I think that's probably the best way to assess it.
So I guess in terms of sustainability and sustainable building, it will help, or it already helps a lot, to optimize and reduce the materials that you build in.
For sure. So again, going back to computing, whereas before an engineer may have a brochure or a few physical samples to refer to, now we've got access to a library of virtually unlimited number of samples. And we've also got software that is capable of, if we don't have a physical test or a physical analysis of a sample, it is possible for us to get a relatively accurate prediction of how that material might behave in a new environment or a new space. And so it gives us a little bit of a bigger sandbox to play with. We can be a little bit more creative in the solutions that we come up with, knowing that we've got this computing power behind us and this ability to compare a virtually unlimited number of solutions and apply them in the correct situation.
In your experience, you've probably encountered many misconceptions about acoustics. Could you debunk a common myth for us and set the record straight on how it relates to sustainable architecture?
Yeah, sure. So that, funny enough, one of the points that we've already touched on, one of the very common misunderstandings is in acoustics is a lot of people confuse sound transmission, the way sound moves from one space to another, and they confuse that with sound absorption, the control of sound within an individual space and how that is being reflected. Because one of the questions I get asked on a regular basis is, if we've got a problem with privacy between one room or another, can we not just add some acoustic panels, some soft panels to the wall? And people will generally think that that will absorb the sound and the problem will go away. Well, unfortunately, those are two completely different principles. It will help a little bit, but it won't help to a massive extent, and certainly not solve the problem that we're talking about. And the other question I get asked a lot about is, can't we just put egg boxes on the wall? And yes, no, is the simple answer to that. Egg boxes look like egg boxes, and they're not really good at absorbing sound or stopping it from traveling from room to room. So I would say egg boxes is probably the biggest one I get asked about on the regular.
I've never heard that.
Oh, really? Oh, okay. Maybe it's a UK centric thing, but I think a lot of people, if they're listening in the UK, would probably have half a smile on their face if I mention egg boxes.
So could you clarify again for the audience, like in 2 or 3 sentences, the difference between absorption and sound travel? Sure.
So sound insulation or sound transmission is the ability of a sound to travel from one enclosed space to an adjacent enclosed space. And you would think of that mainly as privacy, the ability to hear something or someone making a noise next door in the next room. Sound absorption is the control of sound within the room that you are in. So let's just say you had glass windows, marble floor, and you had solid tiles on the wall. That room would effectively sound like a cave. The sound would keep bouncing around forever and ever and ever. Anyone that's been in a cathedral or a church would certainly know how difficult it is to understand the preacher who's giving the sermon. So that Absorption is the control of sound within the space, and the sound insulation, the transmission, is the preventing of that noise going from room to room. In one instance, in the absorption, we need light, fluffy materials that have lots of little air cavities in order to trap the sound. For sound transmission, we need density, we need mass in order to stop the sound going from room to room. So sorry, that was a little bit more than one paragraph.
No, that's great. I think it's quite clear now, the difference. So people won't ask you again about
they will.
boxes.
They will. Every day. Every day of every week. I've joked with somebody the other day, I need one of those electronic dictaphone type things with pre-recorded messages on each number. And then for every question, I could just push the appropriate number. And here's the definition for sound insulation. Here's the definition for absorption. And no, you can't use egg boxes or whatever it is.
So I hope my questions were not limited to those 9 numbers of questions that you always get.
No, you asked some very good questions there.
I have one final question. What advice would you give to young professionals aspiring to make a difference in the field of acoustic engineering?
Well, 99% of acoustics is all about mathematics. So if you've got a passion for mathematics, that's a really good start. I know that there's a lot of computers, a lot of software that kind of do what we do for us to a certain extent, but certainly something that I tell all of my junior engineers is that I don't let them near any computers or any software until we've worked through and demonstrated the ability to do what we do in the old-fashioned way by a piece of paper and a pencil. I think it's very easy for people to simply get a little bit lazy to a certain extent and just rely on software, rely on computers to do all the work. But at the end of the day, you need to be able to understand and recognize that if you've got a strange number coming out of a computer, if you're just blindly accepting what's coming out of the computer, then that's going to end up with bad advice being given to the client at the end of the day. So having a passion for mathematics is pretty important for acoustics. So if you've got that and you've got an interest in architecture, and I think some crazy stat, I've got no evidence again to back this up, but 9 out of 10 acoustic consultants I seem to meet have some kind of background in music, or they're involved in creative arts in one way or another. So essentially, if you like numbers, if you like architecture, and you're interested in music and have no idea what you want to do in your life, give serious consideration to a career in acoustic consulting. Because I have to say, over the last 25 plus years that I've been doing this, no day has ever been the same. I've got a different set of challenges every single day. We're constantly problem solving, coming up with new solutions to sometimes old problems, because not only are you aware of all the solutions that have been applied in the past, sometimes technology evolves and you may get inspired by a solution that's been applied by a completely different discipline or another project, and you all of a sudden find a new way to solve a new problem. So it's an exceptionally interesting career. It's an exceptionally interesting speciality within construction and engineering. And I would encourage anybody with interest in those 3 areas that I mentioned earlier to give serious consideration to acoustic engineering if they're so inclined.
I could listen to you all day long. Can you explain or talk about one of those most interesting challenges you've had?
Okay, so one that immediately comes to mind is a project where we had some equipment on the roof of a building, and this was in the centre of London. And there are some very strict design restrictions in London in terms of line of sight. So when a building is in a kind of pre-concept and they apply to the local council, they give effectively the shape or the outline of the building against the skyline. So, and they have to stick to what effectively they've promised the local authority the building is going to look like very, very strictly. This particular instance, we had some equipment that could, building services equipment, ventilation equipment, that could only be placed on the roof of the building. And the owner of the building didn't want this building equipment to be visible, because he thought, okay, we've got some other buildings nearby that are at the same height or even higher than our building, and we don't want this ugly looking equipment visible to everybody. And so the idea was that we would screen it. We would have these acoustic screens, because these are very noisy, very large pieces of equipment on the roof of this building. And but unfortunately, we couldn't just put the screening up for this equipment to the height that we needed it to be for the acoustic effect that we were looking for. Because to take it to that height would have taken it over that planning condition where we had the restriction on the height of the building. So we had to come up with a design of a screen that was effectively offset, where it would follow the line of the building, but still provide acoustic attenuation. And effectively what we did is we came up with the design of a screen that had a similar principle to a silencer that you might find in an exhaust on a car or a motorbike, where it forces the air through a series of convoluted paths. And every time you make the sound change direction, we had an absorbent material that would reduce the amount of energy that would then be reflected onto the next panel. And then we had some more absorption that reflected onto the next panel. So by the time it went through these series of convoluted paths, 90% of the energy had been reduced, and it was a very effective acoustic screen. At the same time, as rather than having a screen that is this height, by offsetting the second part of the screen, you can see that that line of sight was then achieved, satisfying the planning condition, but also satisfying the noise condition. So on the face of it, you'd think that kind of like sounds relatively simple, but it wasn't a simple solution, but it was a very effective one in the end, which we're very pleased satisfied the requirements of the client and satisfied the requirements of the local regulators to reduce the noise level.
Cool. Thank you so much for the interesting conversation. It was a pleasure talking to you.
And to you. Thank you very much.
If our listeners want to find you and follow your work, where can they look for you?
They can do a simple Google search for the Dubai Acoustic Research Laboratory. That is www.darl.ae. We're based in Dubai, as the name suggests, but we undertake work all over the world. We also have a team in Australia. We have a member of our team in Morocco, and a couple of members of our team throughout Europe. And my email address is technical, because I'm the technical director, technical@darl.ae. They can simply email me any queries or any advice, or if they've got a question, or even better, if they hear anything on this podcast which I may have got slightly wrong and they want to correct me on, by all means, please write to me and let me know.
That's great. Thank you so much, Paul.
You're very, very welcome.
A huge thank you for listening. Make sure you subscribe to the show wherever you listen to the podcast to support me and so you don't miss an episode. And while you're there, I'd also be so grateful if you could rate and review us. If you have any guest suggestions or any feedback, you can find me on the socials @LadinaShipf. Thanks.